Thank you for tuning in. This is training for the Orbit LT utility. Now the new Orbit LT utility is actually available with the Orbit software drivers. So when you download them, it's now available. It's a free package made for adjustments for Orbit LT2 and includes adjustments for surfaces and averaging. Now this is keyed on Orbit LT2 laser, which is excellent for metallic and reflective surfaces. And in fact, there are some adjustments to even get your reading better. One key is that the laser has an oval beam, which is better for metal surfaces with imperfections. In addition, the laser has adaptive surface adjustment. The laser automatically adjusts the beam intensity based on the surface for optimum repeatability. And with this, you can get up to 0.1 microns repeatability. And again, like other Orbit sensors, LT2 lasers can all be networked with Orbit and output to a PC or PLC. So before we get started, you are going to want to make sure that you have the latest Orbit software drivers installed. Make sure you go to the Solartron website, download the latest pack. Once those are installed, go to the Orbit 3 suite. And here, if you'll notice, you have now a new LTA utility. Make sure that your laser is properly powered with one of the PSIMs that you see there, and then connect a USB interface module or Ethernet interface module to a computer, and click LTA utility. So then once you get to this screen, click Find All Modules. Then if you see, this particular number should match the serial number that's on the Orbit module for the laser. We will click OK. As you'll see, this will open up, and this is an Orbit LT2 laser type, module ID 209BW16702. Then here, this is one place where you can adjust the measurement rate. You can adjust this with the Orbit library as well, and you can go anywhere from 250 Hertz all the way to 4 kilohertz. We'll just keep it at 1 kilohertz for now. What you have here are two particular modes that you can adjust before taking readings. First is the target mode, and this has to do with the type of surface that you're measuring. You have three types: standard, multi-surface, or light penetration. Standard is the likely target mode you are going to use the most. It's basically suitable for materials made of ceramics, metal, or filled plastics, but it's material of a consistent nature. So if you're checking, say, a slab of metal and it's the same consistency, then you will want to stick with standard. Multi-surface has to do with if you are checking something with several different types of materials on the surface. The best example of this would be a printed circuit board, which of course has metal, it has plastic, it has all types of different materials. Then the third one is light penetration. So this is where you are checking a piece of material. It's not necessarily glass, but it is something that might be translucent, like what you see in the image there. That might reflect the beam back in a certain way. If you click the target mode of light penetration, that will help the laser adjust to that particular surface. We're going to keep it on standard for now. Now the next is averaging, and you have three different types of averaging here. So first is called moving average. Moving average is something that will help smooth out the data that is coming from the laser. So what moving average is you take the average of a previous number of points, and each time a new point is added, the last one is taken out. Now, if you'll also see, there's current depth. What current depth relates to is the number of points you are using to average. So for example, if you set the depth to 8, then you are taking the average of every 8 measured points. Now this you can of course increase up to 128. The more points you use, the smoother the averaging will be. So this is something where you can use where there's continuous noise but without any type of spikes in the data. And this is also something you can use for low surface roughness and also for short transition response times. Now the next is recursive. Recursive is basically each new measurement value is added as a weighted value to the sum of the previous measurement values. And this can be a range of values from 1 to over 32,000. So this allows an even higher degree of smoothing of the measurement values. However, with this type of averaging, the response time will increase too. So recursive averaging requires extremely long transient recovery times for steps in measurement values. Then the third is what's called median. Median averaging would be something that you would want to use if you are perhaps measuring a surface or perhaps the atmosphere is relatively dirty, like with dust or moisture. Now, what median average does, and it actually takes the median value over a set number of points. So what that actually helps with is if you have perhaps a spike in data from, again, hitting a piece of dust or perhaps hitting a piece of moisture. The median averaging will actually suppress short, strong signal peaks likely caused by those dust or similar elements. Right now, we're just going to keep it to moving. So once we're all set up with a measurement piece, we can click Start Reading. And as you'll see, you have a reading that you're taking right there. And then there's a few extra things here that can help you see the type of quality of measurement that you're getting. First is just kind of a video image in terms of what the laser is seeing. And if you'll see here right now, we are just checking a piece of metal. It's relatively consistent. Actually, it's a piece of aluminum. If you'll see, there's a nice sharp peak here. This is absolutely what you want for your application because as you can see, the reading is relatively stable. Now, if perhaps you're measuring a surface and you see perhaps a wider peak, or if you see two peaks, then perhaps the application needs to be adjusted. Now, if you see two peaks, it's likely because you could be checking a piece of glass. And if that's the case, the laser receiver could be receiving back two different beams. This particular type of laser is not built for checking glass. For that, you could perhaps utilize a different sensor. But again, your main target's to have a nice sharp peak like this. Then if you'll see, there's something called exposure time. Basically, exposure time is also known as the shutter time of the laser. What the laser automatically does is it compensates for different surfaces by altering the exposure time to allow for the optimum amount of light. Now, if it's a light reflective surface, like what I currently have it projected on now, right now I have the laser projected onto a piece of aluminum, you'll see the exposure time is relatively short. However, if a darker surface is measured, such as black, you're going to notice that the exposure time will be longer, just to account for smaller reflections. So now as an example, I'm going to remove the aluminum piece that I have and replace it with a cube that is covered in just simple black electrical tape. Now, if you see, you still have a relatively stable measurement, but the exposure time has increased. Now, the last thing you'll see is the intensity. The intensity is basically the measurement of the intensity of the beam being reflected back into the laser. And it's measured as a percentage. And actually, your target that you want to have is about 80% or above. It's difficult to get to absolute 100%. So if this intensity percentage is perhaps at 60% or perhaps at 40%, perhaps you might need to adjust the target mode or perhaps adjust the averaging to see if that can be improved. So now all of these features and adjustments are available with the Orbit LT2. Now please note the LT laser utility can also be used to adjust Orbit LT1. You can alter the measurement rate between 250, 500, and 1 kilohertz. And also you have 3 different options in terms of averaging. The first is balanced. Balance is actually a moving average over every 64 values. Then there is dynamic. Dynamic is actually a median average over every 9 values. Then there's, of course, no averaging where just the raw data is being fed. Again, you can take the reading from the laser as well. So this concludes the training for Orbit LT Utility. Again, all training packages, including for the Orbit Network, Orbit XL Pack, Orbit GCS, as well as Orbit Gauge Software 4.0 are available on the Solartron YouTube channel. Thank you and have a good day.